Hello everyone, welcome to my GCSE Maths video on vectors. I'm making this video because I've had a fair few requests from my subscribers for it, and I try and give you guys what you want and what you need. So let's crack on. Now all through your maths life you've probably been looking at numbers that represent quantities. You might have had 9 apples. You might have been 10 miles away. Okay? All these type of things are just called numbers, they're just scalars, they're just how many, it's a measure of quantity. Now the problem is, if you were wanting to tell your friend where you were, and you said, well, you know where my house is, I am 1 mile away. That's using a number, we're 1 mile away. Now you might know exactly what you mean, but your friend might not. Your friend might think, well, 1 mile away, where on earth is that going to be? I know where the house is, but actually, look at all these different positions that it could be, all of which are 1 mile away from the house. So just a number on its own is sometimes not good enough. So mathematicians thought, what can we do about this? Because at the minute, we've just got a number, say, I don't know, 3 centimetres. How can we make that better? That 3 centimetres is still 3 centimetres wherever we put it. It's a very good useful measure, okay? But the problem is it doesn't give us any direction. So what we do to change just a normal number into a vector is a very simple thing of changing it into effectively an arrow. Okay? So from now on, let's look at some different arrows and see how useful they can be. So we might say, okay, well here's a vector from the house. Take the vector from the house, that's where I am. Bang on, you're going to get your position. No more confusion. So this thing that we just used is called a vector, and it's the posh word, the posh explanation for vectors is that they have two things. They have magnitude, which stands for the size, and they have direction, which is what we just talked about, often denoted with an arrow to tell you where it's going. So the direction might be actually using a bearing, stroke an angle, or something like that. Okay, so that's the difference between a vector and a normal. Nothing too complicated. So, what if we had a vector? We usually call the vector a letter with a line underneath, so let's call this vector A. What that does is it distinguishes it from just a normal number because it's got the, it's got the line underneath. Now what we can do is we can take these vectors and put them anywhere we want. So even though they're very specific, it depends where we start, where the vector takes us to. And we can actually do some pretty cool maths with vectors, a bit like normal maths. So what if that's A? Well, what if we put another A next to it? What do you think you've done? Well, you've done one A, and you've done another A. So guess what it's going to be? It's going to be 2A. Okay, so this new vector, a whole new arrow, would now be 2A. And you could take this vector and do whatever you wanted with it. That vector is still the same, no matter where it is, it's still facing the same direction, doing the same thing. Okay, something else we can do. Let's do this. So that is the same vector but backwards. Well, A starts here and takes us to here. Well, you, as we said, can start anywhere, but it takes us that way. If we're going backwards, then it's doing the opposite, and we just call it minus A. Okay, so we've just seen that we can add different vectors, we can have negatives of different vectors, and we can multiply vectors. Let's say if we have, let's not make life too complicated, let's go for 3A, and let's see what that would be like. Well, 1, 2, and another one, put them all together, and make it into a whole new line. We'll even change colour. That is now 3a, okay, because it's 3 lots of a, 3 times as big. Okay, so we've talked about this a vector a lot. Maybe we get a bit bored of that. We say, okay, let's introduce a new vector. So let's grab a different colour and let's make a new vector up. Anything we want. Let's do that. Okay, it's a bit shorter than a and it goes completely different direction. So we're going to call that new vector b. Because it's a vector, we need a line underneath it. Now, the clever thing that we can do, I'm just going to do a clone on this so we can repeat it, is we can say, put one vector with another vector. Okay. Well, what's going on here then? We follow the vectors from the start. We start here, we go to here. So we've gone A and we've gone B. So actually the really cool thing now is that new vector that you've just done, if you take a shortcut and instead of going all around the edge, is now called A plus B. Now it gets even cooler. I don't want to overcomplicate things straight away because I want to get on to some GCSE questions, but I want to show you one cool thing. Okay, what we just talked about A plus B. What if I said that we can go any route that we want, as long as we get to that same point, it's still going to be the vector A plus B. So let me show you what I mean. Here's minus A, remember? Let's go minus A, and let's go, I don't know, should we go B? Yeah, let's go B, why not? And then let's go this trusty 2A. Okay, so we've got to that point. I'm just going to use 2 different lines so you can see it a bit clearer. Now when we went that way, it was A plus B. Now what's happening here might blow your mind a little bit, I don't know. Got minus A, we've got B, normal B, because it's in the right direction. Then we've got normal A and normal A. So if we want to go from this point, if it's a point, we can use a capital letter and we'll say AB. And by the way, if you're going from point A to point B, we should use an arrow like that to say from A to B. These are just points, no line underneath. But because of the arrow here, from that point to that point, it makes it a vector. Anyway, what we're doing, minus A plus B, because we've gone along that, plus A plus A. Can anyone see what's going to happen? If you have a number, say 7, and you do 7 minus 7, you get 0. Well, if you have a vector, and if you go along a vector, A, and then go backwards along it, minus A, if you put those two things together, you get 0. So these are going to cancel out, and this is why you might have seen me do algebra with vectors, because it's very, very similar. These cancel out, doesn't matter which order, A plus B, same as before. What did I tell you? Even if you go all around the page, doing whatever you want, made up of crazy arrows, that's going to be A plus B still. Okay? Anyway, hope I've not confused you too much so far. Let's move on to some questions. First one. These are past exam questions, so they should be very helpful. OPT is a triangle. That means if you go from O to P to T, you make a triangle. M is the midpoint of OP. So this point M is in the middle of O and P. OT equals A. Remember I told you that we like to underline? Well, sometimes the people writing the exam think, nah, can't be bothered underlining. Let's just make it bold. They'll know what we mean. Okay? So in reality, it can be underlined or it can be bold. They're going to be vectors. Right, anyway. So O to T is A. We can see that. And what I want to do is use the thing that I was doing before of actually using different arrows. So from O to T, that arrow is our vector A now. T to P, let's get a new one involved. That's our vector B, as we can see on the diagram. Their arrows are in the middle, but I like mine like this. It's just the way it is. Express OM in terms of A and B. Right, so now we've got the challenge of getting from O to M. But remember what I've said, it does not matter what route you go. Okay? Now, question of the day. O to P. What is that vector? Well, we've gone along A and up B. So that is the vector A plus B if you go all the way along. Okay? A plus B. Underline. Now we don't want to go all the way. How far do we want to go? We want to go halfway. Okay? So I probably should have shown you on the previous slide, as well as multiplying by different numbers, we can make it smaller. So there's A. Let me make a note of where halfway is, so I can show you. So from here to here, that's the whole of A. If we go halfway, we can cheat with the computer because it tells us here. Let me try and remember that in my head. There, that's halfway. Okay. If we take this vector now, shrink it down, that is, oh, not that. That is called a half A. Okay. And we can write it as A times a half, or as I usually do, just put the half in front of the A. So that's a little extra handy one for us. Okay, that's what we're going to use now then, because we only want to go halfway across the vector. Well, this whole vector is A plus B. So we want to go a half A plus B, and we've got there. Job done. Looks tricky, but if you understand what's going on, it's all good. Okay, 2 marks. Express Tm in terms of A and B. Give your answer in its simplest form. So now we've got to get from T, which is here, to M. Well, not to panic too much, because we know how to go backwards along vectors. Okay, if we go the other way around A, the other way with A, just picking up the wrong thing, I'm trying to get this arrow here. If we turn that around, go that way, that is minus A, remember? We talked about this. Okay, so if you want to go backwards across a vector, then you better have it as a negative. So there, minus A. So let's put them together. We can go minus A to here, and then half A plus B to there. Okay, put them together. Bit of algebra like before. So half A plus B A plus B, and then what do we say? It was minus A. It doesn't matter if it goes at the front or at the end. Okay, remember it's A star work we're doing here, so if you're getting confused, don't worry about it too much. Right, let's multiply out brackets, because the brackets work. So half of A and half of B, which is the same as a half of A plus B, basically. Okay, you could draw yourself a little diagram to convince yourself, but I've already waffled on for quite a long time. I want to actually get some marks in the bag to help you out. Right, if you've got a half of A and you take away A, algebra comes in handy. That's 1 at A, isn't it? And also knowledge of maths, half minus 1 is minus a half. So your answer is going to be a half B minus a half A. If you want to put them the other way around, go for it, but you better write minus a half A plus a half B like that. Does not matter. The examiner's going to love it either way you do it. OAB is a triangle. So as we said, you go from O, you go to A, you go to B, you join up the points, you get a triangle. Okay, cool. O to A is the vector A. Remember, we underline, they put it in bold. So like I'm saying, O to A here, that line, that arrow shows you which direction you're going, O to A, and so does the diagram. Let's put that on as an arrow right away, and let's use a nice blue colour for that. Okay, so I've done the vector A there. It's still the vector A wherever you put it. Okay, it just so happens at the minute it's going from O to A. O to B is the vector B, so let's get ourselves an arrow on for that one too. Let's go for green. Okay, done. That's the vector b. Find the vector a to b in terms of a and b. So what we want to do is we want to get from a to b. Now we don't know anything about the vectors along here, so we're going to have to go the long way, and we're going to have to use what we know. Now we're going backwards along a, which I hope you're realizing once you get to going backwards along the vector makes it a negative. So far we've done negative a because we've gone the opposite direction. Then we want to keep going, and we want to go along b the correct way. So we're going to just add on b normally. Okay, so minus a plus b. Like I've said, it doesn't matter which way around. I prefer to write it like this so that the minus is in the middle. If I can save myself writing an extra sign, I will, because the plus at the front is invisible. Anyway, P is the point on AB such that A to P, the ratio of A to P, and PB equals 3 to 2. Okay, so let's put a little 3 above AP and 2 above PB. Let's think about what this means. Let's not go to the diagram yet. From A to B, if we take 3 lines across, so if we split 3 lines across, 1, 2, 3, and then 2 here, and we split it up into 1, 2, 3, 4, 5. Okay, so the point is going to be here, which means we've split it up in the ratio 3 to 2. So we're actually in fifths. You add those two up. That makes a bit of sense. Anyway, on the diagram, basically what we just talked about, we can do it here. So that is 2/5 of the way along, and this is going to be 3/5 of the way along. You will get used to this after a bit of practice. Right, so what's it asking us to do? Show that O to P is 1/5 2a plus 3b, and it's going to give us 3 marks if we manage to get it right. So all we're trying to do is get from O to P. So I'll show you the path we're going to go. We are going to go up here and then down here. Okay, got that? Up here and down to P. So when we go up to here, we've gone up A. Now remember, to get from A to B, we've already said what that is. It's B minus A. Okay? And how much of it do we want to go along? 3/5. So all this information together means that we go A, and then we go plus 3/5 of B minus A. Remember, I've said shortcut is the same as the whole way there. It's the same thing, it's the same final effect. Okay, so that was the whole of B minus A. We don't want to go the whole thing, we want the fraction of how much, and that's 3/5. So this is our answer, but it doesn't look much like what we want to show. Does that mean we've done it wrong? Not really. Just means we might have to do a bit of algebra. So, like I've said, you can treat it like normal algebra. It's not exactly the same, but it pretty much works most of the time. Right, 3/5 times B, 3/5 B. 3/5 times minus A, minus 3/5 A. And then you've got the A plus from before. Now, collecting like terms, basically, we've got A, we minus 3/5 A. How many are you going to have left? Well, the whole A is 5/5. It's the whole cake split into fifths, and you've got every part. Take away 3/5, and you're going to have 2/5 left. Okay, don't forget this guy over here, 3/5b. Still not quite there. Okay, still not quite made it. It's looking good though. It's looking okay. Let's just use a notation like that. So what we're going to do is factorize your algebra skills. So you might not think that it looks like it's going to factorize, but it does. And I want to show you one extra step to show you how it factorizes. 3/5 is 3 lots of 1/5, okay? So we've got 1 over 5 times 3b. 2/5 is 1/5 times 2. We've got 2 of them. Okay. Now can you see how it might factorise? Because we've got things in common. We've got 1/5 being multiplied by both terms. So what we can do is we can take out the 1/5 and we can say, okay, let's do it in the right order. Fine, we'll change it in a second. 3b plus 2a equals 1/5 2a plus 3b. Okay, if you've done a really good proof you're proud of, then you can do this little shape, which means you've completed your proof. Okay, but only if it's something really good. Anyway, next one. OAB is a triangle. OA is A from O to A, so let's put that on as an arrow. What colour shall we have for this one? Let's go for a nice lilac colour. Okay, I didn't want it there. There you go. That is the vector A. And we want the vector B, which is from O to B. Let's do that one in red. Gonna have to switcheroo here, I think. Right, fine, we'll use this arrow. It's left over anyway, not doing much. Okay, there we go. We've got 2 vectors. Find the vector A to B in terms of A and B. You know what? This looks like pretty much the same question we've just done. Very, very similar. Fine, I'll show you anyway. It's good practice. Okay, so very, very quickly, we go minus A plus B. Okay, and that's your answer. Doesn't matter which way around you write it. Minus A plus B. 1 mark. Okay. This time, P is a point such that it's split in the ratio 2 to 1. So AP is 2 and P to B is 1 in comparison. So we can kind of see that in the diagram. Now if we make this 2 and this 1, it's split up into thirds. Here we have 2/3. Here we have 1/3. Okay, let me guess, it's going to ask us to go from O to P. Yes, go from O to P, give your answer in its simplest form. Okay, so starting from O, let's do what we did before, which is get to A. To get to A, we use the vector A. Now we want to go not all the way along this vector, but if we did go all the way along from A to B, we've already said that A to B is minus A plus B, aka B minus A. We don't want to go all the way along it, we want to go 2/3 of the way along it, okay, and we want to put these two things together, so we're going to get A plus 2/3 B minus A. Okay, told you it's going to be very, very similar, but it's all good practice. Let's move this down into our working out space. Now we want to simplify, because your question does say give your answer in its simplest form. So let's have a crack at that. Multiply out, you should be used to expanding brackets if you've caught up with me this far. Then you should be fine at this bit. Minus 2/3 A. Now let's simplify. Let's say, okay, you've got a whole A and you take away 2/3. Basically, you've got a whole cake with all your pieces, and someone takes off you. It'd be so annoying, wouldn't it? That piece and that piece. You've got 1/3 left. Okay? That's what happens. Right, a third A plus 2/3 B. If you want to show off, you can factorise. There's no need though. I'll just show you what it would look like if you did. If you did show off and factorise, that's what you get. If you didn't, this is what you'd get. Both are fine because it doesn't ask you to factorise. They're both relatively simple. Okay, moving on. Hope we have a different question this time. Don't want to do the same ones over and over again forever. Okay, let's have an orange arrow this time. So O to A is A, the vector A. We can do it all off the diagram if we really want. O to C is the vector C. So let's put that one on. A OABC is a parallelogram, we can see that. M is the midpoint of CB, okay, that's in the middle of these two. N is the midpoint of AB, that's in the middle of these two. So you know before when we were doing the ratios, saying about splitting up into thirds or fifths or whatever, this is just 1 and 1, so it's just a half and a half, it's split into two. Okay? Right, part A. Find in terms of A and or C the vector M to B. Okay, so we want to go from here to here. Remember I told you I'd be moving vectors around. That vector's A, so bang, that vector's A as well. We're going halfway along it, so the answer is half A. Simple as that. If only life was as simple as maths, eh? Half A. M to N, this again, a little bit more tricky, but I'm sure we will manage it. We want to go from M to N. We can go any route we want. Okay, that's the direct route, which we can't take, but we already know that this bit is a half A, and we know that this is C. But notice which way the arrow is pointing. If we want to go along it, then we have to go minus it. So not only is it minus C, it's minus a half C, because you're only going halfway across. So if you want to go that way, that's minus a half C. So your answer is a half A minus a half C. You'll notice you can factorise quite a lot of those. You could factorise your half in this case if you really wanted to. Why not? I've said it now. Done. Next part. B. Show that CA is parallel to MN. Let's think about what parallel means in terms of vectors. Here's a vector. If I take this vector and copy and paste it, they're parallel. Okay, they're never going to touch, always same distance apart. Well, what if I use the same vector but I make it a bit bigger? Okay, then they are parallel. I'm going to show you a general formula that you can use if you know things are parallel. It's not really a formula, but in general means instead of me using actual numbers, I'm just going to show you for any case that it will work. Imagine this is any old vector W. If you times W by a number, x, then it's not gone any other direction, because this is called a scalar, and it's just either making W smaller or bigger, still going the exact same direction. So if you get a vector times a number, okay, vector times a number, then it's parallel to that vector originally. Okay, so for example, if we've got A, it's parallel to 2A, for instance, okay, as an example. You get the idea. Anyway, show that CA is parallel to MN. So we want to show that one is a multiple of another. So let's figure out CA, and we already know MN. So let's just write down what MN is from a previous question, look. Right, CA, C to A. That's just going to be minus C add A, isn't it? Okay, minus C add A. Or A minus C. Okay, therefore MN equals a half times by this, isn't it? That's A minus C times by CA, therefore parallel. Simple as that, because what I told you about, if you can have a number times it to give another vector, they're both parallel to each other. Next one. OX equals 2A plus B. Very nice. OY equals 4A plus 3B. Express the vector xy in terms of A and B. Okay, so we want to go from x to y. So we want, that's not straight at all. This is why I was using my arrow tool, which was doing well until I tried to do that. So we want from x to y. Okay, we want that vector. Remember I told you it doesn't matter what route we go. Let's go this route and then this route. Now if we're going backwards along the first part, which we are, because the arrow tells us to go the other way, then we need a minus, and it's minus in front of a whole thing. Okay, minus 2a plus b. You can expand that out. You can think of it instead of minus as a minus 1 if that helps, but either way you're going to get minus 2a minus b. You can think of it as bringing the minus inside. Then we want to add this vector, 4a plus 3b, and we can just literally collect like terms. So let me show you. You've got minus 2a plus 4a, that's going to give you 2a, and you've got minus b plus 3b, that's going to give you 2b. Give your answer in its simplest form, that's done. That's 2 marks. Okay. If you want, like I've been saying, you can take the 2 out, but no one cares that much really, surely. Right, so we've got dodgy triangle question. X, Y, Z is a straight line, as we can see. X to Y, XY ratioed with YZ is 2 to 3. So XY splits up into 2 parts, 1, 2, and YZ splits up into 3 parts, 1, 2, 3. So that's 3 out of 5 in total, and that's 2 out of 5, okay? Just a bit of prep work done. Express the vector O to Z, so from here to here, in terms of A and B. Nice. Okay. That looks like quite a tricky question. How many marks we're getting? It's just a straight off 3 mark question. And I think I'm going to have a little think, to be honest. Cracked it. Right, okay. If we figure out what it takes to get from X to Y, that's going to be very helpful. Okay? So let's think about what it takes to get from X to Y. It's going to be minus 2a minus b, because it's minus of the whole thing, to get us to O. And then it's going to be 4a plus 3b. Okay. Now this thing in red gets us from here to here. If we half that, then it's going to get us just halfway to here. Why am I saying we should half it? Because if we half it, and then if we do, just let me get the infinite cloner out, 1, 2, 3, 4, 5 of them, which is times by 5, then that's going to get us to Z from X. Okay, so let's do 5 times that. Now that looks quite horrible. 5 times a half is just 5 over 2. Let's simplify the thing in the middle. Minus 2a plus 4a is going to be 2a. Minus b plus 3b is going to be 2b. Okay, and what's going to happen now is actually, because we could bring out this 2 here and here, it will cancel that 2. This is more A-level type, cancelling that I'm doing now. If you followed it, well done. If not, ask a comment on the comment bit. Okay, that just gets us from X to Z, which is halfway there, but we also want to go from O to Z. So we need this extra bit as well. Okay, so it's going to be, I'm going to expand this bracket now, by the way, 5a plus 5b, and then we need the extra bit, plus 2a plus b, and we're going to get 7a plus 6b. Okay, parallelogram. So what we've got here is A, B, C, D, and all the sides are parallel. Well, this side's parallel to this side, you get the point. Okay, A to B is the vector Q, P, so let's label that on. Okay, let's pick a nice, you probably won't see that, let's go blue. So A to B, that's P, and A to D is Q. Let's go for red colour. Okay, express in terms of P and Q A to C. Well, if you go down to D and then across to C, you've gone Q plus P. Okay, remember it's P. So Q plus P, down Q, across P, B to D. So from here to here. This time we have to go backwards along P, so it's minus P plus Q. If you want, you can write it the other way around. Minus P plus Q is all I'm going to do. Next part. AC and BD are diagonals of the parallelogram ABCD. AC and BD intersect at T, as we can see. Express A to T in terms of P and Q. So we want to get from here to here. Right, now there's quite a cool thing which says that diagonals cross in the middle. So in a very simple example, imagine you have a square. If you do diagonals, that's in the middle of your square. Same with a rectangle, same with a parallelogram. That's bang in the middle. Okay, so what that means is if you go halfway across, you're there, and halfway across there, you're there. So what I'm trying to say is we can go halfway along this line and halfway along this line. So let's do it. Let's go halfway along Q, which is a half Q. And then let's go halfway along P, which is a half P. How did I know it was halfway along P? Because this vector can be picked up and moved wherever you want it, okay? And it's all parallel all the way down. Right, so it's going to be a half of P plus a half of Q, aka, if you really want, half of P plus Q. Why does that work in theory? Because P plus Q would get you, or Q plus P would do this, and guess what? If you do that, you're going half of it. So that's another way you could have thought about it. It's really up to you. OPT is a triangle. M is the midpoint of AB, split in half. O to T is A. T to P is B. Express O to M, so we want to go from here to here in terms of A and B. Like I've just told you on the last question, A plus B is going to get you there. If you only want to go halfway, then it's just half of whatever the whole thing was. Okay, so I know I'm doing it slightly quicker, slightly different ways, but then you've got the whole video to reference. You can use which way suits you. So the whole yellow thing is A plus B, but that gets you too far, that gets you to P. We only want to go halfway, so half it all. Job done. Okay, better put it in the right place just to be nice. Part B. Express Tm in terms of A and B. Give your answer in its simplest form. Right, T to M. Instead of starting from here, we're starting from here. Big wow. All we've got to do is get to there first and then add on what we just did. To get to there, you're going backwards along A, so it's minus A. Okay, so your answer is going to be minus A plus all the stuff from before, plus a half A plus B. We do need to simplify. Let's expand out brackets. Half A plus a half B. Okay, and it's minus A as well. Combine these together. Think of it the other way around if you want, but basically minus A plus a half, or a half minus A. Either way you do it, it's going to be minus a half A. We've still got that thing left, plus a half B. Okay, so that is your answer. 2 marks. Final one I'm going to show you. We've got another triangle. Find AB in terms of A and B. So we want to go from A to B. So we're going to have to go this way from A minus 2A, the vector to A that is. Okay, so minus 2A, and then we can go plus 3B, which is good because that will get us to the destination. Plus 3b. Do not want to write in highlighter. That would be dreadful. Okay, plus 3b. Done. Give me a harder one next time. P is a point on AB such that A to P and P to B is in the ratio 2 to 3. So AP is 2. So let's split it up like I've been doing. That's 2. And P, you can hardly see it anymore, but that's split into 3. So that's in total 5, 1, 2, 3, 4, 5 equal parts, 3/5, 2/5. I will get rid of these lines now because it's making it hard to see. Okay, and the question was, show OP is parallel to the vector AB. So OP is parallel, is that what it says? OP is parallel to vector A plus B. Fair enough. Okay, quite a tricky one. 3 marks, fair enough. Okay, I guess it's the last one we're doing, so that's fine. Right, we've already found AB as a vector. That was minus 2a plus 3b. We want to go 2/5 along it to get from A to P. Okay? So we can write down that we know that OP, I'm thinking of AP, that's why I'm getting confused. A to P is 2/5 of all this stuff up here. Okay? So minus 2a plus 3b. No problem. We can expand this as a bracket, which is going to give us a simplified form, which is going to give us minus 4 over 5a plus 6 over 5b. Now that is just getting us from A to P. If we want to go from O to P, we need A to P and a little bit extra. Okay? And if you want, by the way, OP is the same as O to A plus A to P. And if you understand what these arrows are doing, then that'll make perfect sense to you. So all we need to do now is figure out how to get from O to A. Well, O to A is 2a. It's already told you. Okay? So it's 2a plus, or sorry, minus 4 over 5a plus 6 over 5b. We need to simplify this. Now, if you've got 2 holes, that is the same as having 10/5. If your cakes are cut into 5, you need 10 slices to have 2 holes. So that's 10 over 5a minus 4 over 5a. Guess what? That gives you 6 over 5a. So this is going to work out very, very nicely because we've got 6 over 5a plus 6 over 5b. And we can now do the F word. We can factorise 6 over 5a plus b. And that, as I've said, shows that it's parallel to the vector AB. Okay, therefore parallel to A plus B. Right, that's all I want to show you on vectors. Quite a long video. This is A star stuff. If you followed me all this way, well done you. Okay, and I hope your study and your revision is going well. I really hope I'm helping on your journey to achieving maths. Thank you to all my subscribers who've given me such positive comments, and I do really hope that you're going to do your best in these exams. Okay, thanks for watching. See you next time. Achieve Maths.